This is the second video in a series going over the freeform ladder diagram portion of the KAS IDE software. In this video, we're going to go over adding functions and function blocks and how you would fill in the inputs and outputs required to use them in a program. Going back to the program I started in the first video, I'm going to now add some function blocks to my ladder code. If I go to our function block library, the most basic piece of code in the ladder program can be found under PLC Standard, the Standard section, and that's the 1 or copy block. So you're basically multiplying by a factor of 1 or just writing the value from the input to a variable that's on the output. You can use a coil, so I could double click to select a variable, drag it, use that contact, and do the same thing. So this is a little bit tricky for new ladder users. You have to click it once, then click it twice, not a double click, so you get it highlighted, and then you can move it. And that's the same if I was going to do multiple objects or just one cell. Once you get it highlighted in that little darker color, then you can click it again to drag and drop. I'm going to double click on the inputs, and this will have a pop-up, and once again I can either select a variable, create a new variable, or in this case I'm just going to type in a brand new value or a constant. On the right side are the output, so this is where I'm going to write a value of 100 to a variable. I'm going to create a new variable, call it command velocity. And I don't want it a Boolean value, I want it to be a long real. Now when I run this code, if I make the new variable true, a value of 100 will be written to the command velocity variable. Also, you'll note when I drag this function block out, I can just use it right away. More advanced functions, or function blocks we call them, you have to create an instance for them, and that's because it needs its own individual set of internal variables. A copy block, or most of the basic math functions, are just that, functions. There's only one possible output for any combination of the inputs, so you don't have to create an instance of it. It doesn't need its own internal memory. But for a lot of the PLC open function blocks, or ones that work with our AKD drives, you're going to have to create an instance of the function when you drag it out. So for instance, even an MC read act pause function block, when I drag it out, I'll get a pop-up. And this is so I have to create an instance of this function block, and it will show up in the dictionary. So I'll call this read axis 1 position. And our ladder editor, once again, is smart, so it'll pre-fill in the type that that function block has to be, that instance of the function block. So this is an MC read act pause function block. Also, now if you need a little more space, you can drag the little lines on the top or on the left to globally increase the space of all the columns or rows. You can also hit the plus or minus keys on your keyboard to globally zoom in and zoom out as well. For this function block, instead of having a contact, I'm just going to grab a line or trace horizontal line and drop that in. So directly connect this function block to the power rail. This is because I always want to read the axis positions, so it doesn't make any sense to have a contact where sometimes you'll be reading, sometimes you won't. I'm going to double click on the axis input. In this case, I'm going to select an axis that was already created, that is already in my dictionary. And then outputs are optional. You do have to fill in all inputs for function blocks, or else you'll get a compiler error. But in this case, I'm just going to fill in the position output. I don't have to fill in anything for all the others. And once again, since the output has to be a long real, it'll pre-fill the type in on our ladder editor. I'm now going to compile and download this code and then run it and show you the animation in our ladder editor. You'll see once the program is running, The program is now animating, so not only does the power rail highlighted in green to show power flow, also you'll see the state of any variable will show up as well. So right now command velocity is 0, my axis position is 10.299, and you can also highlight a variable, and just like we could hit spacebar to toggle through the different types of contacts and coils, when you're editing your program, when it's running, you can hit spacebar to toggle true and false. So now, since I enabled this variable, I enabled the want or copy block, and now my command velocity is no longer 0, but now 100 because this function executed. Also, you can double click on non-Boolean variables to get a little pop-up to force the value to something different if you would like. Another trick in the ladder editor that's helpful, even if you didn't fill in the outputs, if you have a function block that has an instance of it, you can open up the watch window. So if I go view watch window, since I didn't have it open previously, you can, right from the editor, select, drag that instance of the function block into the watch window and open up, and even if you didn't fill in any of the outputs, since this instance is in your dictionary and all the internal variables are kept, you can view them in the watch window. So this is a nice helpful troubleshooting measure if you weren't going to use the outputs in your program but you didn't want to see the state of them while your program is animating. You can do that through the watch window. That's the end of this video. We will have one more to show some more advanced features of the ladder editor and why we call it a freeform ladder diagram editor.